So, any change in motion that you observe or any change in motion that you feel is caused by a force, okay? So initially, this golf ball was just sitting still. It wasn't rolling at all, okay? And that's because the forces acting on it were balanced. So, the force of gravity pushing down on the ball was balanced by the force of the ground pushing up on the ball. The forces were balanced. And the net force, therefore, was zero. Now remember, net force is the combination of forces. So the combo there was the force pushing down on the ball combined with the force pushing up on the ball. Those combined to cancel each other out, aka the net force was zero. The ball was sitting still and the net force was zero. Okay? This all changed when I applied the force of the golf club to the ball. Suddenly, the forces acting on the ball were unbalanced, okay? And the ball moved in the direction of the net force, okay? That's what caused the ball to move. And this is an example of Newton's first law of motion, which says that an object at rest tends to stay at rest unless a force is applied or a force acts on the object. The same thing goes for objects that are in motion, okay? Newton's first law also states that an object in motion tends to stay in motion unless a force acts on it. Now, we don't see this here on Earth because we have the force of gravity, we have the force of maybe wind resistance. There's numerous forces acting on this ball as it, say, flies through the air. Okay? So we don't see that on Earth, but we would see that in space. So in space, where there's no gravity, no wind resistance, and no force of the ground pushing up on the ball, causing friction, the ball would just go on forever and ever and ever. Alright? So, Newton's first law states that an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless a force acts on it.